Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we're back streaming live on a Tuesday. Last week, we had the rare event of a Wednesday live stream, and what a live stream it was. We covered an introduction or a preview of Seascape 10, and we had a tremendous number of people that watched that live and watched it on replay. So I'm glad you enjoyed it. And over the next few months, we're going to work on getting Seascape 10 rolled out, so there'll be plenty of more content for you. This week, we've got another good topic. Here it is. Discover little known but useful system registers. Now, there are a lot of ways that we come up with topics here on the channel. Sometimes I come up with them. Other times we get ideas from tech support, and many times we get ideas from viewers like you. Now, this week, the idea for little-known system registers came from my colleague, Tom Philippek. Now, you may remember Tom. He's been on our channel once or twice to talk about OEE, but Tom thought it would be a terrific idea to share some of the little-known system registers that people don't think about when they're working on their application. So that's what we're going to do today. All right, let's take a look at how we're breaking down today's topic. Okay. We're going to start, of course, by answering the question, what are system registers? We're also going to discuss the difference between bit-type system registers and word-type system registers. And of course, based on our topic today, we're going to take a look at those that are overlooked that might be useful in your program. We're going to give you plenty of application examples, and we'll have demonstrations throughout. All right, here we go. Okay, so what are system registers? System registers are a type of OCS variable or register that is predefined with a certain meaning. And that meaning generally relates to communicating system status or some other parameter that's embedded in the OCS. Now, system registers are typically read, but there are some that can also be written to either from the screen or in logic to maybe adjust a system setting or to perform some sort of useful function. Now, most parameters that you'll find in the system menu have a corresponding system register allocated to them. So that'll give you an idea of kind of what their origins are. Now, there are two different types of system registers. There are the bit type or %S and the word type or %SR. Now, system bits are relatively few. There's only 13 of those, and we'll review those here in a minute. Whereas system registers are more numerous, and there are as many as 222 of those, kind of divided between the standard system registers and the extended system registers. Now, the best place to find information on system registers are in the user's manual or in the help file, where you will find some detailed tables giving you all the information that you could want to know. Now, do keep in mind that depending on the model of OCS that you're using, or even the language that you're using, the number of system registers that are supported and the specific ones that have meaning does vary. Okay, so let's start with those 13 system bits. And these are ones that are probably the most used by most users. Now, system bits are read-only, so there's no such thing as a read-write system bit between S1 and S13. And you'll find the most commonly used one in this list. As an example, first scan. So %S1, that bit is on for the first scan of the logic scan, and then it's off after that. So we use that one to do things like set variables to their initial values and all those sorts of things. S7 is always on and S8 is always off. We use those very frequently as well, especially always on when you've got a rung that doesn't have anything but a function block and you need to start it with a contact. Always on, of course, is the one that we use most frequently with that. Now, some other system bits that are pretty useful include those that represent a pulse. So there are 3 system bits that are on for a specific period. They're basically a pulse. And you've got a S3 bit, an S4 bit, and an S5 bit. So S3 has a 10 millisecond period, S4 100 millisecond period, and S5 a 1 second period. And for each of these S bits, they are on for the first 50% of the period and off for the second 50% of the period. Now, S5 can be particularly useful. That's the one with a 1-second period. It can be particularly useful as a flash bit. So you'll find customers using that one periodically for that function. Okay, now a vast majority of the system registers are the word type, the ones arranged from SR1 to SR222, and that's where we're going to spend a bulk of our time today talking about those. Now, keep in mind that unlike S bits, which are read-only, SR bits are a mixture of read-only, read-write, and the read-write ones are divided between those that can be written from logic or written from the screen or written from both. So in your manual and also in the help file, you will find the details that tell you whether each system register, SR type, can be written to or not and where it can be written to from, whether it's just the screen, just the logic, or both. Okay, so let's start with some of the overlooked system registers, starting with SR3. Now, SR3 indicates the currently displayed system screen. Now, how can that be useful? Well, first of all, let's talk about SR1 and SR2, which are not overlooked. So SR1 is the user screen number. So SR1 always contains the value of the screen if a user has selected the current screen to be displayed. In other words, it wasn't forced to be displayed from logic. It was displayed based on a user choice. So that's SR1. Now, SR2 is called an alarm screen number. So that's going to display the current screen number if the current screen was forced to be displayed. Usually that's done from logic with a D-type coil. So how is System Register 3 different, and what is it useful for? Well, System Register 3 is going to display the value of the current system screen that's displayed if there's a system screen displayed. So in other words, if the customer goes to the system menu, all right, then you're going to see a value show up in SR3 that indicates which of the system menu screens he's on. And on the right there, you can see a complete list, or at least it's complete as of now, that shows all the different screens he might be on as he navigates his way through the system menu. But what's more useful is the ability for an application designer to write to SR3 to force a specific system menu screen to be displayed, to provide a shortcut for their users to go in and, let's say, change the time and date. So instead of creating a time and date screen on their own as a system designer, you just create logic that effectively writes to SR3 a value of 10, and then that sends them to the set time and date screen. So that can be pretty useful. Some of these other screens can also be useful. These other system menu screens can also be useful, but by far, the most useful one is for setting the time and date. So let's go ahead next and demonstrate that. Okay, let's start out on the bench where I have created a screen that demonstrates what I just talked about. So we're displaying the date and the time on the screen here, and I've created a push button which is going to allow me to jump to the place in the system menu where the clock is set. So let's go ahead and do that now. So when I press this button, you're going to see me jump to the system menu. Now, I didn't press the system screen or anything like that. Okay, so let's go ahead and make a change. Let's change the time here. All right. And then when I hit escape, you'll notice I go right back to the screen I was on before. So that's the beauty of this capability, is you can jump to a particular screen on the system menu, but as soon as they press escape, they're going to come right back here. Now, another thing I can show with this demonstration is that if I set the value of SR3 kind of manually here, and there are 24, I believe, different system screens, okay, so I just need to set it to a value somewhere between 1 and 24. Oh, I just did that one before. I guess we're going to do it twice in a row. Okay, and let's change this one to 11. And you can see I can jump to just about any system menu screen that I want by manipulating SR3. Now, what did this button do here that caused me to jump to the time and date screen? Well, basically what it did was it triggered logic in my program that copied a value of 10 into SR3. So that's how that worked And if we take a look at Cscape, we can see indeed that's what's happening. I've got a push button which is pressed from the touchscreen, and it's causing a value of 10 to be written to the syscreen variable, which is mapped to %SR3. Okay, so that's the capability to jump to a particular screen in the system menu system from logic by writing to SR3. The next overlooked register we're going to take a look at is System Registers 35 and 36, which work as a pair. And between the pair of those, they provide a unique serial number for every OCS. So the two values, when taken together as a double integer, so SR35 as a double integer, effectively guarantee when you read those values, you're going to have a unique number assigned for every OCS. Now, how does that work? Well, effectively, what SR35 and SR36 represent are the portions of the MAC address, the MAC ID, the Ethernet MAC ID, that are changeable on a per unit basis, or that are unique on a per unit basis. So every device that resides on Ethernet that's produced in the world has to have a unique MAC address. That's a requirement. And manufacturers are assigned prefixes for their MAC addresses, and Horner is no different. So we have a series of, we have a series of MAC addresses that we are assigned, and the prefixes are always the same. So the fixed prefix in our case is 0E0 in hex. That is not changed or not unique on every OCS. So therefore, that's not even part of a system register because it's always the same. However, the next octets are contained, the ones that are unique, are contained in SR35 and SR36. So if you look at the bottom right of the screen there, you can see that if you take a look at SR35 as an unsigned double integer, you have 32 bits, effectively, that are unique, whether you display it in hex or whether you display it in decimal. Okay, so that can be very useful in several cases, whether it is to examine as part of your program the serial number of the current machine, comparing it against some sort of target to see if it matches, maybe as an extra security assurance against your machines being duplicated, in an unauthorized fashion. Of course, there are other features in the Horner OCS and in Cscape to help protect your intellectual property, but this is an additional tool you could use to compare the serial number of the current machine in your program versus what you're expecting it to be, when it was deployed, for instance. And then it also could be used to reconstruct your MAC address, if you will, to display that on the screen or something like that. So it has a variety of different functions. All right, so next, let's go ahead and demonstrate how that might be used. Okay, let's go ahead and start out on the bench here as we take a look at SR35 and SR36. Okay, so the first thing I'm going to show you is that as part of a data field here, I'm showing you SR35 as a 32-bit value. So that, of course, incorporates SR35 and SR36. So I'm showing it to you first in hex, and then secondly, I'm showing it to you in decimal. Now, this value that you're seeing here, the specific value, is unique to my specific XL7 that I have here on the bench. So for your particular OCS, or every particular OCS that you use, this value is guaranteed to be unique. Now, I also mentioned you can use it to reconstruct the MAC address for the unit. If you take the fixed prefix, which on every OCS is always 00E0, and then if you take a look at SR36 as a hex number, and then SR35 as a hex number, those three consecutively make up the Ethernet MAC address of the OCS. Now, I'm going to show you one way you could use the serial number, the uniqueness of the serial number to your advantage as a machine builder. So we know, of course, that our serial number is effectively this, and it's unique for this OCS. So we could create some sort of algorithm in our logic which takes the serial number, runs it through some sort of math function, for instance, and then comes up with a unique answer, and then uses that for some sort of authorization code so that you know that if the authorization code that, let's say, is entered manually at the deployment time of your machine, if that matches what it should based on the serial number algorithm, then you know your machine is effectively authorized, if you will. And if it doesn't match, you know there's an issue, and you can make the machine not necessarily operate, and of course display some sort of phone number or some sort of message that indicates that, as again an extra function against, counterfeiting or something on that nature, or the illegal use of your program, that sort of thing. Now, be careful in how you use these sort of things. This is an example, and be careful how you use this. Make sure you're not using it to violate any laws or anything like that. Okay, so in this example, our authorization number, and again, I didn't run it through any kind of algorithm. I just made it a one-to-one scenario here. So if my authorization number matches, which it does right now, everything is good. But let's say for whatever reason, the authorization number didn't match. All right, I'm just going to put some bogus authorization number in here. Well, it doesn't match anymore, and boom, look, what do we have? We've got a message showing up saying, hey, we've got an authorization error and you need to contact us at our phone number before you can continue. And how does this work in logic, the way at least I've programmed it? Well, if we take a look at Cscape in this section of the code, we'll go down here and see that if the serial number does not match the authorization number, then we're going to force this screen to be displayed. Now, of course, in a real application, you're going to have more than just a equal, not equal comparison. You're going to have some sort of algorithm, and you're going to hide, of course, probably using OEM type features. You're going to hide the logic inside the algorithm. But in other words, this gives you an idea of how you could use the serial number to your advantage, potentially as a machine builder. Now, to kind of get me out of this demo type hole I'm in right now, let's go back to the bench, and I've incorporated a fix button so that I can go back to normal operation and go back to demonstration as well. Okay, so that's an illustration of possibly, what the serial number system registers could be useful for, so that in your logic you could somehow access those serial numbers, the unique serial number of SR35 as a double integer, in some sort of algorithm to make sure your machine is authorized. Okay, the last overlooked system registers that we're going to examine today are SR171 and 172. So these provide touch coordinates for the latest place on the screen, or the current place on the screen that is being touched by the user. And SR171 contains your x-axis coordinates, and SR172 contains your y-axis coordinates. And when you create objects in Cscape and place them on the screen, the lower left-hand corner of that object is the X and Y coordinate for that object. And then, of course, where you press on the screen at runtime, or where the operator presses on the screen at runtime, is going to be based, of course, on the XY coordinate where his finger, or her finger, and if that case may be, touches the screen. Okay, so this can have a variety of uses. You can use it just monitoring these registers. If they're both 0, if SR171 and SR172 are both 0, you can know that the operator is currently not touching the screen. And if they're non-zero, you know the operator is currently touching the screen. So that's one use for that. Another use is effectively knowing precisely where on the screen an operator presses. So you can use this as an alternative to kind of hidden or non-visible push buttons that you may want to place on a graphic or something. So when an operator touches a graphic, something happens. Maybe it's a screen jump, or maybe it's activating a particular bit or something like that, like a push button, that sort of thing. If you want to use the touch coordinates as an alternative to a hidden push button or a hidden jump button, that's certainly an option that you have. Okay, so let's go ahead and demonstrate how these could work in an application. Okay, we are back on the bench. Let's go ahead and demonstrate how touch coordinates can be used in an application. So I'm going to go ahead and just press the screen here, and you can see as I press at different locations, I'm going to get different values in my X and Y coordinate. Okay, so that is pretty useful for knowing precisely where on the screen an operator is pressing. Now I've drawn a little target here in the middle. If I hit anywhere in this target area, I've got ladder logic, which is watching for that. And if that ever occurs, if those X and Y coordinates ever are inside this target box here, then something will happen. Let's take a look. Okay, I pressed, and sure enough, I switched to a screen. So I used the X and Y coordinates almost like a jump button. Okay, and then I can go back to where I was before, or back to the home switch, or home screen, if you will, and then back to the touch coordinate screen. Again, nothing happens when I'm touching out here, okay? But when I touch in the target area, because it matches a range of values that I'm looking for, I can use it like a touch button now, or like a jump button. So let's take a look in Cscape and see how that was accomplished. So it's really just some simple logic that effectively says, okay, if we are on screen 4, so D4 is the contact that is tied to this particular variable, because I'm using variable-based advanced ladder. So if we're on screen 4, so D4 is on, then, and if our X coordinate is between 368 and 496, okay, that's the start and the end of the X coordinate for that box. And if my Y coordinate is between 207 and 335, then I'm going to go ahead and switch to screen number switch using the D6 coil, which is tied in this case to a variable called screen 6. Okay, so that's really all there was to it, to utilize the X and Y coordinates to cause the screen to switch. Now, the way to ensure that this works in variable-based logic is to make sure that you've allocated, or that you've mapped, the appropriate system registers. In this case, 171 is the X coordinate and 172 is the Y coordinate. So in variable-based advanced ladder or in IEC, make sure as you create these variables that you map them to the appropriate system register locations for them to operate properly. And in the case of my earlier demonstration of the serial number, unique serial number capabilities, I have created a variable called MAC low, which is tied to SR35. So that's the low word of the MAC address. And I created a variable called MAC mid, which was tied to SR36, which will give you the middle value of the MAC address. And then the high value is just a constant that is always the same regardless of which OCS you have. So that'll give you an idea of how you can map these system register locations to your variables in variable-based advanced ladder, and it works the same way in IEC. All right, so that covers the material I wanted to share with you today. Now, there are plenty of other system registers that are useful. I'm going to go ahead and revisit this topic in the future, so we will cover more useful system registers in the future. All right, but let's wrap up today's topic. Okay, so system registers, %S and SRs, they're predefined registers that provide system information. They're usually read-only, but some of them can be written to, and that can make them pretty useful, and we showed those today. Most of those were writable system registers we illustrated today, except for the touch coordinates. Those were read-only. They showed us precisely where on the screen the operator was pressing currently. And of course, keep in mind that the best information for system registers is inside the help file in Cscape or in the user's manual. And we covered several of those little known but useful system registers today, including ones that allow you to jump to specific screens in the system menu, show where the operator is touching the screen, and revealing the unique serial number, which is a part of the MAC ID for each OCS. All right, so we hope you found today's topic useful, and we'll revisit in the future with some additional system registers that are useful as well. So this is the part of the show where I tell you that we're here every Tuesday at 2 o'clock. Now, for those of you paying attention during the demonstration, during the real-time clock demonstration, you probably saw that we pre-recorded this particular video because I'm on vacation as this video is streaming live. But as this video is streaming live, we have folks standing by answering any questions you might have if you're watching it live. If you're watching this on replay like a lot of you do, just give us those comments and questions in the comment section, and we'll be more than happy to get those responded to quickly. All right, we'd like to remind you we're currently celebrating our 10th year of Horner Lighting Group products, so don't hesitate to check out the Horner Lighting Group videos that are located alongside our automation videos on the Horner APG YouTube channel. Now, don't miss the opportunities which are approaching fast for training. Now, for basic OCS training, that class I believe is still full, but advanced training still has openings for August 8th through the 9th. Now, next week, we're going to be covering using the Horner Wi-Fi adapter. This is an accessory that can be really useful if you want to add Wi-Fi capability to an OCS that has an USB-A port available to it. So the micro OCS does not have a USB-A port. It only has mini B, but for the XL series and the XL Prime series and some of the RCCs, at least one of the RCCs at least, you'll have an opportunity to use Wi-Fi with those products if you choose so. All right. So at this stage, this is also where I remind you that if you have not subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do us some good.